With the advance of AI technologies, now it has become handy to build an AI model with the help of various AI platforms. However, to provide a service with an AI needs more practices other than building an AI, for example, resource orchestration and/or communication between service components. Suppose that someone built a very good AI model and wants to deploy it to the cloud to provide a service. The environment to run AI will be different and it needs communication methods to make an AI as a service. From the cloud side, it needs to be able to handle acceleration resources and design an efficient architecture to reflect various characteristics of AI along with other services. One of the purposes of Decenter platform is to help developers build AI services in a more intuitive way by reducing this gap between AI and cloud technologies. To this end, Decenter provides various methods such as resource orchestration, App Composer or Decenter AI package. This video will present the various functionalities of Decenter in a Smart Office AI service. Let's think about a Smart Bulletin Board service with AI. Instead of displaying the same information repeatedly, this Smart Bulletin detects an individual's affiliation and displays only the appropriate information immediately. In this use case, the AI method in this use case is to detect an affiliation from the camera's video stream. Though this service looks simple, it needs a few considerations to place the AI model. When it's placed on the cloud, it will consume a lot of bandwidth since it needs to receive video feeds from cameras, and there might be a consideration of privacy issues. On the other hand, placing it on the device itself will increase the cost of hardware and make maintenance complex. Decenter provides methods to distribute AIs over cloud and edge with microservice architecture, which makes it easy to build an AI service over cloud and/or edge. And in this example, we're going to compose the service with 3 AI models. The first AI model will find the faces from the received video. The second AI model will extract features from detected faces for comparison, and the last AI model will do the comparison to find the affiliation of the person. Decenter provides a Decenter AI package, which enables building an AI microservice from an AI method. The 3 AI microservices are built with this Decenter AI package. Decenter provides a tool to build service architecture in an efficient way, the App Composer. Using the App Composer is quite straightforward. First, you build a topology by dragging one of microservice or endpoint to the main window pane, and connect them with arrows. When the service topology is ready, we can set deployment of the microservices with GUI. With this GUI, we can request specific resources such as GPU or location, as well as other specifications to Kubernetes deployment. Here, we can specify specific GPU resources to run the AI microservice. And we can specify where to deploy the AI microservice. This App Composer provides methods to configure AI microservice as well. You can specify which AI model to use, and input-output connection of the AI microservice. Decenter provides Decenter AI package and AI model repository to build an AI microservice in an efficient way. Sometimes the model is too big to fit in the edge resource. We have applied a pruning method to the AI model for the first AI. We were able to reduce about 21% of the model size with the proposed pruning method, while preserving the accuracy. You can check how the microservices are deployed with this GUI. Now we can see that all the services are deployed on proper edge resources. Let's see how the service works in the real world. As we've seen before, this use case is composed of 3 AI models, the one to detect faces from videos, another one to extract features from the detected faces, and the other one to find affiliation by comparison of those features, and we can check how they are working with this GUI. The incoming video and FPS of the first AI method is displayed on the far left, detected faces are displayed in the middle with the second AI, and the far right displays the detected affiliation. Various metrics of serving an AI such as FPS, delay or confidence score are displayed in this UI. As mentioned before, Decenter platform provides methods to distribute AI methods on proper resources. You can choose where to deploy your AI methods, on edge or on cloud resources, or on high-performance GPU edge or on embedded devices. Let's put some different resource requirements with App Composer and see how it affects the performance. First we'll deploy the first AI method to the embedded device, and then we'll deploy the last AI methods to the cloud. We can check the effect of different resource requirements with this GUI. The graph on bottom left shows comparison of performances between GPU and embedded edge node for the first AI model. The graph on bottom right shows end-to-end delays of different placement of the last AI model. You can easily assess the performances between various configurations with dCenter. The key performance indicators of this use case demonstration includes reducing model size by 20%, engaging at least 2 models, and accuracy higher than 80%. The use case pilot is working on to achieve those KPIs in year 2, and will continue improving the platform in year 3. dCenter is a platform to improve cloud technology for delivering AI service, and this demonstration showcased 3 important aspects of them. dCenter provides ways to transform an AI method to a microservice with dCenter AI package and AI model repository. dCenter proposed an AI model optimization method for AI to be runnable on resource-constrained edges, and the App Composer provides intuitive methods to design and configure the end-to-end AI service. The improvements in cloud technology by dCenter are summarized in this figure. dCenter is an ongoing project, and will continue working on integration in the coming project year to bring a more advanced cloud platform for AI along with IoT. Thanks for watching. For more information, please visit our website, dcenterproject.eu.